All right, here's a lesson on graphing rational functions. So a rational function is in this form, where p at x and q at x are the numerator and denominator. All right, so what are some steps we're going to do to graph this? And so you can see steps of simplifying, intercepts, asymptotes, and so on. So one thing we need to remember is this word degree. We're going to remember degree is the greatest exponent, just as a reminder. So if the degree on top is bigger, then there is no horizontal asymptote. The next lesson will be on oblique asymptotes, and then that will come into play. If the degree on top is less than the one on the bottom, then it's y equals 0. And if they are equal to each other, we take the power term of p of q and the power term of q and divide, and it'll be a number. And so the power term is the full term that includes the degree. And then we're going to sometimes have a hole in the graph. So a hole is a point that's undefined rather than a line. And to find it, when you simplify, the factor that gets crossed out creates a hole in the graph. So when that happens, we're going to find where the undefined point is rather than an asymptote, which is a full line. All right, let's look at number 1. And we're going to go through the steps to find different things. So here I first look to see, is it factorable? Could I simplify it? And the numerator and denominator are prime. To find the x-intercept, that's the 0 of the numerator. So if I look at the numerator, what is the 0, or make it equal to 0 and solve it? Where is the intercept? And our intercept's at 4. So I'm going to go that right now. 1, 2, 3, 4. Our x-intercept's at 4. There it is. Our vertical asymptote is the 0 of the denominator, our h. Remember, it's the opposite number, so it's negative 4. So I'm going to draw a vertical line at negative 4. Our horizontal asymptote, we look at the degree. So I can't see the exponent, but the biggest exponent in the numerator is 1, and the denominator is 1. They're equal. So to find the horizontal asymptote, I take the power term on top, which is just x, and the power term on the bottom, which is x, and divide it, and I get the answer 1. So go 1 up, and it's 1. There is no hole because nothing simplified. So if nothing crosses out, it doesn't create a hole. The domain is what x cannot be, which is this negative 4. And the range is what y can't be, which is this horizontal asymptote, which is 1. Now, I have one point here, and I'm going to use it. I'm actually going to find one more thing, the y-intercept. So I'm going to do that over here. To find the y-intercept, you plug in 0. So if I plug in 0 and solve it, I get negative 4 divided by 4, which is negative 1. That's called the y-intercept. So I'm going to find that. That's right here. And then I'm going to connect the 2 points together that I have, and this is that curve of a rational, like a reciprocal. Now, I need a point over here. So I have one curve, but I know there's 2 curves. So the asymptote is at negative 4. I need to pick a point to the left, an x value. I need to plug it in and solve to get a point to curve through. So I'm just going to pick the number to the left of negative 4. And that would be negative 5 to find a point to curve through. So I'm going to take the equation and I'm going to plug in negative 5 and then solve it. So negative 5 take away 4, and then negative 5 plus 4, and then solve it, and I get positive 9. So at negative 5 and positive 9, I have a point for my graph. I could also plug in -6 or -7 and get more points, but I just want 1 point. So I know in terms of the direction and how it's going to curve using that 1 point. When I ask you for the end behavior, you're going to say where the horizontal, this right here, gives you the end behavior for both left and right. So it's going to go to 1. And you did it. All right, let's try another one. Number 2. There's lots to practice here. I'm going to tell you the bell's going to ring soon, so I won't get too many done, but I'll do another one, another video soon. All right, so step number 1 is I'm going to factor this. So I'm going to factor out a 2. That leaves me with x minus 3. I want to see if something crosses out. It doesn't. The x-intercept is what makes this 0. So if the factor is x subtract 3, the opposite number, positive 3, makes it 0 on top, and that's the x-intercept. The vertical asymptote is the denominator, the opposite number that makes it 0, which is 1. That's also going to be the domain. The horizontal is by taking the power term on top, which is 2x, divided by the first term on the bottom, which is x. The x's cross out and leave you with 2. So go up 2 and do a horizontal asymptote. There is no hole because nothing simplified crossed out. The range is the horizontal, what y can't be. And then I'm going to curve using this point. Now, one thing I found on the last graph I'm going to do here too is the intercept, the y-intercept. They have only the x-intercept, but there are 2 intercepts. So the y-intercept is when you plug in 0 for x and then solve it. Now, the good thing about 0 is that when you multiply it, it's 0. So you're left with -6, and here you're left with -1. So that gives me positive 6. So I'm going to find where positive 6 is, put a point there. Now I have a point on both sides of the vertical asymptote. So I don't need another point. I'm going to use that point. I'm going to curve up, and then to the left it curves down and follows. The last thing I want to write down here is the end behavior. And the end behavior is the horizontal number. That's your k value, which is 2. So both ends are going there. So as x approaches infinity, f at x approaches 2. As x approaches negative infinity to left, again the function approaches 2. I'm going to try one more. All right, number 3. This is factorable. So step 1 is I can factor it. That's called a difference of squares. So the square root of x squared and the square root of 1, that gives me x plus 1, x minus 1. Now, at this step, what is the 0 of the denominator? What's the restriction before I cross it out? And it's positive 1. So I'm going to write that in right away. Then I'm going to cross this out. Notice something crossed out. That means there's a hole in this graph because I crossed out. What did I cross out? X minus 1. Make what you crossed out equal to 0 and solve it. So we're going to add 1 and x equals 1. Then I'm going to take that answer 1 and plug it in and solve. Now this is what's crossed out. So all I'm left with here after I cross out is x plus 1. So I take this answer and I plug it in here, and 1 plus 1 equals 2. That's my y coordinate. So I have a x coordinate, this is our hole, at 1, and a y coordinate at 2. The vertical asymptote, we have none, because all I have is x plus 1. There's no denominator anymore. So once I cross this out, all I have is x plus 1. I don't have any 0 in the denominator, so there's none here. The horizontal, notice the degree on top is bigger than the bottom, so there's no horizontal asymptote. We do have an x-intercept. What is the 0 of this? What's the opposite number? So that is on my graph. So I have -1, and I have a hole at 1, 2. And I'm going to draw a circle to represent the hole. and then I'm going to connect. There is no curve here because we don't have any asymptotes, so it's just a line with a hole in it. The range is the y value of the hole. So the domain is the x coordinate and the range is the y coordinate of what y can't be. And I'm not going to, the end behavior actually for this one is to infinity and negative infinity. So without a horizontal asymptote, this goes up in one direction and down in the other direction. Number 4, I'm just going to go for it. I'm going to factor the denominator. So that's a diamond, simple diamond, 5 and 4. So I'm going to write that in, 5 and 4. Right now I'm going to write down the restriction from the bottom. So what can x not be from the denominator? Negative 5 and negative 4. Then I see something crosses out. And so after you cross out, I have a 1 on top and x plus 4 on the bottom. So what crossed out was x plus 5 equal to 0. Subtract 5, and the x coordinate of my hole is at negative 5. Then I take that number and I plug it in to find the y coordinate. So I'm going to take out x and plug in negative 5 and solve it. So negative 5 plus 4 and solve it. I get my two numbers for my hole, which is negative 5 and negative 1. Now, in the denominator, I still have x plus 4. That is going to create a vertical asymptote. So we have two restricted numbers. One restricted number creates a hole, and one creates an asymptote. We have no x-intercept because we just have a number 1 there. Nothing makes the top 0. So we have no x-intercept. The horizontal asymptote, the denominator has a bigger degree than the numerator, and when that happens, the horizontal asymptote is at 0. And the hole here also creates a number that y can't be, which is negative 1, and the other number is going to be 0. All right, from the asymptote. So let's graph this, and this will be our last one for this video. So we have negative 5 and negative 1, that's a hole, so I'm going to put a circle there. I have a horizontal at 0. I have a vertical at negative 4. And I have no x. But you know what? I do have a y-intercept. If I plug in 0 for x, 0 plus 4 is 4. I have 1/4. That's okay. 0 and 1/4 is like right there. So this is what it's going to do. It's going to go to the hole and then hop over the hole. Using that y-intercept, I'm going to curve and use it. So I now have two curves, one curve with a hole in it and the other going through the y-intercept. If I wrote down the end behavior, our end behavior goes to the horizontal, which is 0. So I'm going to put it right here. As x approaches infinity, f at x approaches 0. As x approaches negative infinity, f at x also approaches 0. And we did it. All right, Mr. G Math over and out. I'm going to keep practicing with the lesson. And we know the more we practice and listen and do our best, it's going to get easier, right? So I'm proud of you for sticking with this. This is a challenging lesson, but one that I know you can do. Till next time.